Hello, hi everyone. Welcome to the Student the Brand. So today we are going to discuss about light reflection and refraction chapter. So in the previous class we discussed until light reflection. So in this video we are going to discuss about light refraction. Light refraction. Okay. So we'll see now light refraction. The light refraction chapter will discuss. So in the previous video, so we discussed about light reflection chapter, light reflection and refraction, complete reflection explained. Now we are going to discuss about refraction chapter, refraction. So light refraction part we will discuss. So refraction is nothing but the bending of the light and the interference of the two media. The bending of the light and the interference of the two media is called refraction. The bending of the light at the interference of the two media. Now, so if the light ray passing from rarer to denser, the light ray passing from rarer to denser, if the light ray passing from rarer to denser, so at the point of interference, the light ray will bend at the interference. Okay, so we can check here. So here light refraction chapter, light refraction will discuss light refraction, light refraction. So what is the refraction? Refraction is nothing but okay. So light ray is moving. Well, light ray is moving from rarer to denser. If the light ray is moving from rarer to denser, I'm taking this is a rarer medium, denser medium, rarer medium, denser medium. Light ray is moving from rarer to denser, rarer to denser. Okay, light ray is moving from rarer to denser. So here, like this, I'm taking like this. Okay, light ray passing from rarer to denser. It bends at the interference of the two media. It bends at the interference of the two media. So here, like this, I'm considering. Okay. So here, this is the angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Angle between incident ray and normal line is called angle of incident. Angle between refracted ray and normal line is called angle of refraction. Angle of refraction. Okay. Now, laws of refraction, laws of refraction, laws of refraction, laws of refraction. So point number one, point number one, point number one, point number one. incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line lies in the same plane. Incident ray, refracted ray, normal line lies in the same plane. Okay. So second one. So sine of angle of incidence to sine of angle of incident to sine of angle of refraction equal to constant. Sine of angle of incident to sine of angle of refraction equal to constant n. So once again, loss of refraction, incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line lies in the same plane. So sine of angle of incident to sine of angle of refraction equal to constant. Sine of angle of incident to sine of angle of refraction equal to constant. Okay, so this is about loss of refraction. So n is the refractive index. N is the refractive index. N equal to C by V. N equal to C by V. C by V is nothing but absolute refractive index. N equal to C by V. C by V is nothing but absolute refractive index. N equal to C by V. C by is absolute refractive index. So speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium, that is called absolute refractive index. Coming to relative refractive index, that is N12 relative refractive index, that is N21 equal to N2 by N1 equal to V1 by V2. Here you can observe. So N2 by N1, N21 equal to N2 by N1, that is equal to V2. So I hope it is not clear. So now you can see N2 by N1, N21 equal to N2 by N1 equal to V1 by V2. Okay. So refractive index, absolute relative refractive index. This is relative refractive index. This is absolute refractive index. Absolute refractive index N equal to C by V is absolute refractive index. Relative refractive index is so speed of light in medium. Medium 2 with respect to medium 1, that is, so N2 by N1 is equal to V1 by V2, so this is about relative refractive index, absolute refractive index and loss of refraction. I hope it is very, once again, loss of refraction is nothing but incident ray, refracted ray, normal line lies in the same plane. Incident ray, refracted ray, normal line lies in the same plane. So sine of angle of incident to sine of angle of incident to sine of angle of refraction equal to constant, that is n. So n equal to C by V. So ratio of speed of light in vacuum by speed of light in medium. So observe, relate this absolute refractive index. So with respect to speed of light in vacuum or air, if you are taking, that is absolute refractive index. Relative refractive index is n equal to N2 by N1 is equal to V1 by V2, right? Yes, this is the relative refractive index. We can also take N21. So N21 also we can write N21, that is N12 if you are taking N1 by N2 equal to V2 by V1, right? So this is about relative refractive index. I hope it is very clear. Okay, I will give one problem. So related to refractive index, I'll give one problem. So we'll do it. Okay. Chalo then. So now I'll give the question. Check once. So this you can see there's a question. This is a question. Try to solve it. 2.5. Try to solve this question. You can check this question. So speed of light is 3 into 10 power 8 meter per second in vacuum. What will be its speed in diamond of refractive index 2.5? So how can we do it? Can you solve this problem? How to solve it? So simple, easy. The formula is n equal to c by v. N equal to n equal to c by v. So c equal to already given 3 into 10 power 8 meter per second. Okay, c already given. C equal to 3 into 10 power 8 meter per second. Right? And n equal to c by v. This is the formula. Now substitute. So n refractive index already given, n equal to 2.5. N already given 2.5. N is 2.5. N equal to 2.5. Okay. Now, so C already given. We can find out the formula. So formula n equal to C by V. So 2.5 equal to 2.5. 2.5 equal to C 3 into 10 power 8 meter per second by V. So we need to find out V value. We need to find out V value. How to find out V value? So V equal to 3 into 10 power 8 by 2.5. Can anyone say the answer? What is the answer? Answer? Anybody know the answer? Can you tell? Yeah, correct. Sumaya, correct. 1.2 into 10 power 8 meter per second is the correct answer. Yeah, very good. Very good, correct answer. 1.2 into 10 power 8 meter per second. So like these problems they will ask, like this type of problems. Okay, so like this. So we'll go to the next topic. Like that, few more problems also I'll give. So just write this question. Very simple question, but very important question. What is the define absolute refractive index? Can you define absolute refractive index? Define absolute refractive index. Absolute refractive index. So absolute refractive index is equal to absolute refractive index n equal to C by V. Absolute refractive index equal to n equal to C by V. C by V, right? Now, so here if you are taking, normally if the light ray passing from rarer to denser, it bends towards the normal line. Normally if the light ray passing from rarer to denser, it bends towards the normal line. It bends towards the normal line. If the light ray is moving from denser to rarer, if the light ray is moving from denser to rarer, it moves away from the normal line. Yes or no? Okay, so that's why this is the rarer medium and denser medium, rarer to denser. Light ray is passing from denser to rarer. Light ray is passing from denser to rarer, so it's moving from denser to rarer. So here you can take, if the light ray is passing from denser to rarer, it moves away from the normal line. It moves away from the normal line. It moves away from the normal line. Like this. Angle of incidence and angle of refraction. So if the light ray passing from denser to rarer at certain angle of incidence, the refracted ray passes gauges along the surface. The refracted ray passes or gauges along the surface. The refracted ray passes or gauges along the surface. So if you am taking here, so angle of incidence, light ray passing. So if light ray passing along the normal line, along the surface, so here you can observe, this is the light ray passing from denser to rarer at certain angle of incident. At certain angle of incident, the refracted ray passes along the surface. Refracted ray passes along the surface, gazes along the surface. Okay, gazes along the surface or makes 90 degrees with the normal line. Makes 90 degrees with the normal line. So that angle is called critical angle. That angle is critical. That angle is called critical angle. The angle at which the refracted ray passes or gauges along the surface is called critical angle. So same, if the light ray is passing from denser to rarer, if the light ray is passing from denser to rarer, okay. So denser to rarer here same. Light ray is passing from denser to rarer. So the refracted ray makes more than 90 degrees. The refracted ray makes more than 90 degrees. So that angle is called. So that time here you can observe the light ray is passing from denser to rarer. Light ray is passing from denser to rarer. So if it makes in the rarer medium, it makes more than 90 degrees or more than 90 degrees, more than critical angle, that light ray will reflect back into the same medium. So now you can observe here, right? Now you can observe. So the light ray is passing from denser to rarer. Denser to this, the light ray passing from denser to rarer. So it in the rarer medium, it makes more than 90 degrees. It makes more than 90 degrees. More than 90 degrees. That is the reason it reflects back into the same medium. It reflects back into the same medium. So that is called total internal reflection. Total internal reflection. Once again. So light ray is passing from denser to rarer, it moves away from the normal line. It moves away from the normal line. So at that the angle at which the refractor makes 90 degrees with the normal line, that is called critical angle. This is called critical angle. Again, if the light ray passing from denser to rarer, it makes more than 90 degrees in the rarer medium, it reflect back into the same path. So that's why it is called. Okay, that's why it is called. So that light ray will reflect back into the same medium. Then this is known as total internal reflection. Total internal reflection. So next one, we are going to the one more, that is glass slab. We'll discuss glass slab. This is a glass slab. Light ray is passing from rarer to denser. Light ray is passing from rarer to denser. Okay. So this is a rarer medium and denser medium. Light ray is passing from rarer to denser. Rarer to denser. Light ray is passing from rarer to denser. So it bends towards the normal line. It bends towards the normal line. Yes, glass slab. Glass slab. So it bends towards the normal line like this. Again, if it is passing from denser to rarer, it moves away from the normal line. It moves away from the normal line like this. So if you are extending the incident ray, the light ray will become parallel to the emergent ray. The light ray which is, so this is the emergent ray. This is the emergent ray, okay. So this is the incident ray, refracted ray, emergent ray. Incident ray, refracted ray, emergent ray. Incident ray, refracted ray, emergent ray. Okay. Light ray is coming from rarer to denser, bends towards the normal line. If it is passing from denser to rarer, away from the normal line. If you are extending this incident ray, it will become parallel to the emergent ray. So that will become parallel to the emergent ray. So the distance between emergent ray to and extended incident ray, the distance between emergent ray and extended incident ray is called lateral shift. This is called lateral shift. Lateral shift. Lateral shift. Okay, once again, if the light ray is passing from lateral inversion is nothing but phenomena of convection of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. Okay, lateral shift. Okay, understood. So once again, if the light ray passing from rarer to denser, it bends towards the normal line. If the light ray is passing from denser to rarer, it moves away from the normal line. So the angle between incident ray and normal line is called angle of incidence. Angle between incident ray and normal line is called angle of incidence. So this is called angle of incidence, angle of refraction, and angle of emergence. I hope it is very clear, right? Okay. So next one, related to this one, there are 3 questions are there. If the lemon is placed in the lemon is placed, laws of refraction already we discussed. Incident ray, refracted ray, normal line lies in the same plane. The ratio of sine of angle of incident to sine of angle of refraction equal to constant. The ratio of sine of angle of incident to sine of angle of refraction equal to constant. That is about laws of refraction. Laws of refraction. Okay. Next. So if you are placing the, so I'm taking the beaker like this beaker. So I'm taking the beaker. If I'm standing here, so if I place the coin at the bottom of the beaker, if I place the coin at the bottom of the beaker, I can't able to see. So this the beaker, coin is placed at the bottom of the beaker. I can't able to see when I'm standing here. Once you pour water, once if you pour water, if, after pouring water, so the coin position I rises up. The coin position rises up here. Okay. So the distance between apparent position to actual position of the coin. The distance between actual position to apparent position of the coin. The distance between actual position to apparent position of the coin is called vertical shift. Is called vertical shift. Vertical shift. Vertical shift. Okay. So this is about vertical shift. Once again, so the distance. So normally, if you place the coin at the bottom of the beaker, so normally you can't able to see. After pouring water, the coin position rises up. The coin position rises up. The distance between actual position to apparent position of the coin, the distance between actual position to apparent position of the coin is called vertical shift. So lateral displacement is the distance between emergent ray to and incident ray direction. So initial direction of the incident ray. So the distance between emergent ray to and initial direction of the incident ray is called lateral shift. Vertical shift is the distance between actual position to apparent position. Actual position to apparent position. Actual position to apparent position. So that is called vertical shift. Vertical shift, right? So one more, if you place the coin, if you place the lemon inside of the water beaker, water beaker or water tumbler or water glass, okay, so inside of the glass water is there. If you place the lemon, then it appears bigger. So normally you see the in front of the shop, so there is a glass inside of the water, they'll place the lemon inside of it. So it appears bigger. It appears bigger. It appears bigger. Yes or no? So that is also refraction of light. Refraction of light. And one more example. One more example you can take. So I am placing the pencil. So I am placing the pencil. Pencil, if you take pencil, I am taking the pencil here. So now you can observe here. So this is the pencil. Okay. This is about pencil is placed inside of the water tumbler. So at the position at the position of the interference between water and air, at this position, the pencil appears to be bent. The pencil appears to be bent. Actually, so it won't bend. So it appears to be bent because of the refraction. So these three examples will get okay. Any of these three questions, one question can be expected in the exam. Any of these three questions, one question can be expected. Okay, one is coin placed in the beaker, another one is lemon placed in the beaker, third one is so pencil placed in the water beaker, right? So any of these three questions, one question can be expected in the board exam, right? So next, we are going to the next question. So convex lens. So we'll discuss convex lens. Now, so we will discuss about one more, that is lens. So convex lens, convex lens, convex lens. So I'm taking the convex lens. Convex lens I'm considering here. Convex lens. Convex lens. Convex lens. Convex lens. Convex lens. Convex lens. Right? Next. So ray rules of convex lens. So optic center F1, 2F1, F2, 2F2. So light ray is coming from infinity. Light ray is coming from infinity after refraction passes through F2. Light ray is coming from infinity after refraction passes through F2. Okay, like this. And the second one, optic center F1, 2F1, F2, 2F2. Light rays pass through the focus. After refraction passes, become parallel to the principal axis. And coming to third one, light rays passing through optic center F1, 2F1, F2, 2F2. Light rays passing through the optic center, there won't be any deviation. There won't be any deviation like this. Okay. Next one, we are going to the one more ray rules. This is for convex lens. Convex lens ray rules. We'll go to the concave lens. Concave lens. We'll discuss about concave lens. Concave lens. Concave lens. Concave lens. Okay. One object. So here you can take same. First one. Optic center F1, 2F1, F2, 2F2. Light ray is coming. So light ray is passing like this. After refraction, so it will passes through focus F1. Second one, okay, those who have any doubt, okay, so check once. You can comment after the class, live class. You can comment. I'll answer. So you can go to the any videos. You can answer. Try to answer. Ask questions in those videos, or you can check once. So my Instagram link is there. So in the YouTube channel, just go and ask there also. I'll answer. Okay. So if you have any doubts, you can comment. So maybe in the class I may not respond. Due to explanation. So don't worry about it. So go and ask any question after the video or after the class. You can post a message. Okay, or you can go to any video and post. Definitely I'll try to answer it. And YouTube Instagram link is there, so in the YouTube channel, so you can go to the main main YouTube channel. So go to the link. Already Instagram link is there, so I'll provide to you. So just you can ask the question in that. I will provide the Instagram link. Check once now. So 1 minute. So that is the Instagram link. I pinned it. Just check once. So if you have any doubts, okay. Now, so light ray is passing. Focus F1, 2F1, optic center F2, 2F2. Okay. So light ray is passing through focus. It passes through F2. After that, it will become parallel to the principal axis. So next, so third one. Optic center F1, 2F1, F2, 2F2. Okay. So here light ray is passing through optic center. Light ray is passing through optic center. No deviation takes place. It moves through like that only. So I hope it is very clear. Once again, light rays, so in this case, light rays become parallel to the principal axis after refraction, passes through focus. So light ray passing through focus after refraction become parallel to the principal axis. Light ray passing through optic center. Light rays passing through optic center. Okay, no deviation takes place. So this is about concave lens image formation, concave lens image formation. Now we will discuss about convex lens, convex lens, convex lens image formations. So now we'll discuss about convex lens image formation. So convex lens, first one, convex lens image formations. Object is at infinity. Object is at infinity. Image will form at. Object is at infinity. Image will form at F2. F2. Nature of the image is real and inverted. Size of the image is highly diminished. Coming to the next one. Next one. Optic center F1, 2F1, F2, 2F2. Object is placed beyond central curvature. Object is placed beyond central curvature. So image will form between so as I said, due to explanation, I couldn't able to answer it. So Instagram link I given to you all, so you can check once. And whatever you have doubt, Charita. So if you have any doubt, you can ask. You can post a message. So regarding your doubt, yeah, beyond central curvature here beyond 2f1, beyond 2f1. So image will form between F1 to F2, F1 to F2, like here. So object is beyond to F1. Image will form between F1 to F2, F1 to F2. Nature of the image is, yes, 10th syllabus only. Ion, 10th syllabus only. CBSE grade 10 physics. CBSE grade 10 physics. So you can check if you have any doubts, you can. So object is placed beyond center curvature. Image will form between F2 to F2. Nature of the image is real and inverted. Nature of the image is real and inverted. Size of the image is diminished. Size of the image is diminished. Okay. So this is second one. Coming to third one. Object is placed. So those who are, you can go and check the. So go and check the Instagram page. So if you like it, you can follow the Instagram page also. So already mentioned. Next. Optic center F1, 2F1, F2, 2F2. Object is placed at center curvature like 2F1. So image also will form at 2F2 itself. Image also will form at 2F2. No, same size ma. Not diminished, same size. F2 and 2F2. So object is I am taking here. One light passing through optic center. So image will form here. Okay. Object is 2F1. Image will form at 2F2. Object is placed at 2F1. Object is placed at 2F1. Image will form at 2F2. Nature of the image is real and inverted. And size of the image is same size. Same size. Okay. So next one. Next one, fourth one. Optic center F1, 2F1, F2, 2F2. Object is placed between F1 and 2F1. Object is placed between F1 and 2F1. How many light rays are required to form the image of the object? Where image will form? How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object, right? So I am taking here 1 light ray. So it passes through focus. Another light ray is passing through optic center. So those light rays will meet. Those light rays will meet beyond to F2. Okay. So object is placed between 2F1 and F1. Object is placed between 2F1 and F1. Image will form. Image will form beyond to F2. Beyond to F2. So object is placed between 2F1 and F1. Image will form beyond to F2. Beyond to F2. Nature of the image is real inverted and enlarged. Real inverted and enlarged. Okay. So I hope it is very clear. Once again. So whatever you have doubt, you can post. You can post if it is there. I will address your doubt. Whatever you have doubt, Kirti, if you have any doubt, you can post. So message in the chat that I will answer. Okay, so now go to that. Object is at infinity. Image will form at F2. Nature of the image real inverted and size of the image highly diminished. And the next one, object is placed beyond to F1. Image will form between F2 and 2F2. Nature of the image real inverted diminished. Object is placed at 2F1. Image will form at 2F2. Nature of the image real inverted and same size. Okay. So next one, object is placed between 2F1 and F1. Image will form beyond to F2. Nature of the image is real inverted and enlarged. Real inverted and enlarged. Right? Clear? Yes, of course I will. So I'm teaching CBSE physics. Renu Bala. So user ID. We'll see. Not now because I'm going with the CBSE grade 10 physics. So those who are there, now you can check my Instagram page. You can follow. You can follow the Instagram page. It's already a link. I given the link. Check once. Okay, done. Now, so two more. So object is placed at F. One more, and object is placed between F and O. Those who want to know the reason behind of this costume, you can go and check. One side is, so we can't say one side, half of the lens. So Maya, if half of the lens is covered, will lens form image? Yes, it will form. So half of the lens is covered with the black paper, black coating or black paper with okay. So with remaining half it forms, but intensity it will reduce. Okay, so previous how it is formed, that much intensity won't be there, but so intensity will reduce. Full image will form. Okay, done. Next one. Convex lens. Optic center F1, 2F1, F2, 2F2. Okay, object is placed at F1. Object is placed at F1. So fifth one, object is placed at F1. Object is placed at F1. So one light ray I am taking like this, it passes through focus. Another light ray passing through optic center. So object is at F1. Image will form at infinity. Nature of the image is real inverted and highly enlarged. So here object is F1, image will form at infinity. Nature of the image is real inverted and highly enlarged. Real inverted, highly enlarged. Sixth one. So object I am taking optic center F1 to F1, F2 to F2. Object is placed between F1 and O. So one light I am taking like this, it passes through focus. Another light ray passes through optic center. If you are extending those light rays, if you are extending, so image will form same side of the object. Okay. Object is placed between F1 and O. Image is forming same side of the object. Same side of the object. Image is forming same side of the object. Image is forming same side of the object. Okay. So nature of the image is virtual, erect and enlarged. Nature of the image, virtual, erect and enlarged. Virtual, erect and enlarged. I hope it is very clear. Once again. So this is about convex lens. This is about convex lens. So now we will explain concave lens. Concave lens. Concave lens, only two image formations. Optic center F1, 2F1, F2, 2F2. So object is at infinity. Object is at infinity. Object is at infinity. So how many light rays are I am taking? 2 light rays. Minimum 2 light rays are required to form the image of the object. So I am considering here. So object is at infinity. Image will form at F1. Image will form at F1. Nature of the image is virtual erect. Virtual erect and highly diminished. Virtual erect and highly diminished. Coming to the next one. Next one. First and second. Virtual erect and diminished. Okay. So this is about here. Image will form at F1. Nature of the image is virtual erect and so user ID what the hector. Thank you so much. Okay. Now here object is placed beyond 2F1 like between P and infinity. Image will form between F1 and O. Nature of the image is virtual erect. Virtual erect and diminished. Virtual erect and diminished. Power of lens is positive for convex lens. Power of negative for concave. Power of lens is positive for convex. Power of lens is negative for concave. Power of lens is positive for convex lens. Power of lens is negative for concave lens. Okay, few questions I will ask. Try to answer it. Few questions I will ask. What is the refractive index? Absolute refractive index. What is the absolute refractive index? What is absolute refractive index? So I'm responding to everyone. So I'm answering, I'm reading your messages. So don't worry about it. Okay. So try to answer the questions. Absolute refractive index. What is absolute refractive index? Can you tell me absolute refractive index? Definition of absolute refractive index. So those who like the content, those who like my explanation, please do like, share and subscribe to Student the Brand. You can share to your friends, ask your friends to join. So Instagram link is provided. So I pinned the message also in the comment. So check once and try to follow the Instagram page also. Right. So come to the point. Absolute refractive index. What is absolute refractive index? Absolute refractive index. Sriji, congratulations for getting 95. So for your percentage. Absolute refractive index. No one. Okay. Refraction in daily life. Anyone can tell the one example for refraction in daily life? One example for refraction in daily life. One example for. One example. Okay, very good. Sumaya, very good. Next one. Refraction in daily life. One example. Anyone can say one example for refraction in daily life. Okay then. So we'll see. Total internal reflection. Example. Total internal reflection example. Anyone can say? Total internal reflection example. So hi everyone, welcome to the channel. So those who are yes, Mirages, very good. So those who are new to the channel, so do like, share and subscribe to Student the Brand. So I already given Instagram link, you can follow. Okay, done. What is the vertical shift? Very good. Diamond shining is correct. What the actor? Very good, correct. Vertical shift example, can anyone? Class 11. Yeah, I'll start. Class 11 and class 12. So vertical shift example, anyone can sell? Anyone can tell a vertical shift example? Coin in bezel. Vertical shift. Okay, very good. Any other example? Lemon. No, definition. Or definition I'm asking. Okay, coin place, lemon place. That is a refraction example, Charita. And Sumaya, yeah, very good. Okay. Okay, so thank you so much. Dispersion and diffraction. Okay, one more example, one more. Absolute refractive index, relative refractive index. Okay, one more question. If the object is placed at F in convex lens, if the object is placed at F, where image will form? What is the nature of the image? If the object is placed at F, where image will form? What is the nature of the image? Anyone? If the object is placed at F, object is placed at F, where image will form? Object is placed at F. Object is placed at F in convex lens. Very good. Infinity. So what is the nature of the image? Nature of the image. Nature of the image. Okay, image will form at infinity. No, object is placed at F, image will form at infinity. Nature of the image is highly enlarged. Highly enlarged. Real and inverted. Nature is real and inverted and highly enlarged. Highly enlarged. Real inverted, yes. Real and inverted, highly enlarged. Okay, thank you so much for joining and attending the class. So we'll see. So we'll see in the next class, 9 o'clock. 9 o'clock. Supriya, hello. So 9 o'clock you can join to the class. We'll see. We'll discuss one more chapter. So thank you so much for joining and attending and listening the class. So we'll see at 9 p.m. Thank you so much. Those who are there. Nainika, hi. Yes, today only. Surendra, today only at 9 p.m. So join to the 9 p.m. class. So we'll discuss. So thank you so much for joining. So those who like my video, do like, share and subscribe to Student Brand. So you can follow the electricity chapter will do. Electricity chapter. Thank you so much. We'll see you in the next class.